guys, and great to see you again. Today we're gonna have a very good conversation around RPKI security, benefits, and its adoption. So I would like to introduce our speakers. Nathalie Trenaman, Routing Security Program Manager at RIPE NCC. John Curran, ARIN CEO. Melchior Aelmans, Chief Architect at Juniper Networks. And also Ignas Anfalovas, Engineering Manager at IPXO. So today we're gonna talk and expand a little because, well, we don't have much of a time anyway. Because we can talk, I guess, hours and hours about RPKI and the security of the internet. So today we're gonna touch base on the most important things and where we're going with it. So I would like to begin from Nathalie, and perhaps you can enlighten our audience. What exactly is RPKI?
Yes, thank you. I'm going to explain you a little bit first exactly what RPKI is and how it came to be a while ago already, and what the problem is actually that we're trying to solve here, because you can only see the need for a tool, RPKI is a tool, if there is a problem, right? So can I have my slides up maybe? So I'm not sure about if everybody is very much aware of BGP, Border Gateway Protocol that we use to route packets on the internet. Probably you are, but just to make sure everybody's on the same page, bear with me for 3 minutes while I give you a 3-minute crash course into BGP and how RPKI came into play with that. So BGP is old. It is very old. It's 35 years old. And when they invented BGP, Border Gateway Protocol, it was meant to get packets from A to B in the most efficient way. There was no security built in, nothing like that whatsoever. So you have a simple BGP protocol that routes traffic from A to B, where basically the routers tell each other, I am the legitimate holder of this IP block, and I'll send it to you, and then a routing table is built. I'm making a lot of shortcuts here for brevity. Next slide, please. So we have this Border Gateway Protocol, but in the beginning, in the early days of BGP, 35 years ago, there were not many players on the internet. So everybody kind of knew each other. So you knew that Patrick was running network B and Ignas was running network C, etc. And if there was trouble with something or something broke, you would simply call each other. And for that reason, we also have in our region the RIPE database, but every region has a database where that contact information and that routing information is stored. So you could actually verify in that database, who is the rightful holder of a block of IP addresses and what the routing intention actually is. There is a little bit of a problem with that, because it could happen that because people need to update these databases, people forget to update these databases. And that happens a lot in reality. We see other people taking over a network, or there's a merger or acquisition, and people forget to update this information, the routing information and the contact information. So while this was a good idea, those databases in the early days of the internet and later on as well, over the course of the years, we see this is becoming more problematic. The lack of maintenance. There are many of these databases around. And who do you trust with the right information in the databases? Next slide, please. And then we have the human factor on routing as well. And we saw that today as well with Cloudflare. You were probably impacted, or maybe not, then you got lucky. We were, as RIPE NCC, where accidents happen. Now in BGP, BGP is not a very forgiving protocol. And that means that if you say that you want to originate a specific block of IP addresses, the 2 and the 3 are really close on your keyboard. You hit commit, and then it happens, and you, by accident, are completely announcing the wrong prefix from somebody else. Or policy violations, where you announce something on the internet that wasn't supposed to be announced on the internet. And incidents attract media attention. Now, I have to say the incident today on Cloudflare could not have been avoided by RPKI. There is always that element that you can't catch everything. Can I have the next slide, please? But some incidents, well, first of all, we see a lot of incidents. When you ask a room full of network engineers who never made a typo in BGP, maybe one finger goes up in a full room. I've been a network engineer ages ago. I made mistakes as well. So you've got the route leaks, mostly they're accidents, but nowadays you also see a lot of BGP hijack events where people maliciously want to steal somebody's IP addresses. So, next slide, please. This is where RPKI came into place because in around 2009, 2010, people started thinking and discussing in the Internet Engineering Task Force, where they make RFCs, we have to do something about that. We need to have trustworthy routing statements that can be verified, on which we can make proper routing decisions. So they developed resource public key infrastructure. Many people think the R stands for route or routing, but it's not. It has to do with resources, with IP addresses and AS numbers. And it follows the hierarchy of the registries. So RIPE-NCC is a registry, ARIN is a registry, and we serve as what we call trust anchors. Basically, what RPKI allows is to make authorized statements from resource holders, but this time certificates come into play. So these are cryptographically signed objects to make the proper verification all the way up in the tree. Next slide, please. So what it does, it allows IP address holders, so that would be you, to create digitally signed and verifiable statements about your BGP routing intentions, how things should be seen on the internet. And it allows network operators to make informed and trusted routing decisions based on those statements that they can verify. That is in a nutshell RPKI. I have 2 more slides. Can I have the next one, please? Because the certificate structure, you see the little anchors there. That is because each of the 5 regional internet registries is a so-called trust anchor. We don't have a single root in RPKI. We've got 5. And our members and PI holders can generate a certificate, and under that certificate, make these routing statements that we call route origin authorization objects. And then in the end, for last slide, then we have routing on the internet where people make those statements. All those routing statements called ROAs are collected in RPKI repositories, see that as the database, and routers can pick up that information so the operators can validate that information and make routing decisions based on that. I think that's it for now.
Yeah, thanks a lot, Nathalie. Actually, it explains a lot and why we need it and, why it was introduced. And, how RPKI solves, the things from the actual network. Perhaps, Ignas and Melchior could enlighten a little bit about it, from the network standpoint, as from the providers and from a solution architects.
Sure. I guess I can start, Melchior. Are you okay with that?
Go ahead. Sure.
Okay, so as Nathalie has mentioned, the BGP is old. It's really old, and It was created then internet security was not a major focus, and as Nathalie has also mentioned, sometimes typos happen and they cause some traffic redirections, which end up in route leaks, route hijacks, and IP address spoofing. As I mentioned, this does not have to be like intentional abuses. They sometimes just misclicks and stuff, but they actually end up in causing slow internet speeds, unreachable paths of internet, or worse, traffic rerouted via malicious networks. And also Nathalie mentioned that today's Cloudflare incident, which could not have been prevented by using RPKI, but I actually found one, a perfect example, which maybe could not have been perfectly prevented, but at least could be minimized. So yeah, one of this example is incident which happened a bit more than a year ago. It was on April 16th, 2021. And it was actually a BGP hijacking event. I will not go into much detail about it. I will just try to make a point about the RPKI. So basically, it ended up with AS 55410, which belonged to Vodafone, mistakenly announcing over 30,000 prefixes, which caused a spike in misdirected traffic. Some of those prefixes belong to Google, Cloudflare, Fastly, and others, affecting their services. Of course, it was not done intentionally in any way, but the cause is not actually known. What is weird about this case is that the upstream peers should have clearly seen the significant rise of the prefix number, the increase, and they should have, I think, dropped the announcements in any way. And of course, the AS 55410, it was not the origin of these prefixes, so it was clear case that it could have been prevented. But the most important part of this is that around 80% of these hijack routes had no ROAs, meaning that their route origin was unknown. And if they did, the most of these would have most likely been filtered out by the network operators. And I guess that is the main importance of the RPKI, that you can minimize the hijacking or the other internet incidents in a major way.
Absolutely. Melchior, what's your...
Yeah, sure. Yeah. So to add to that, I think the good thing is that the majority of incidents are indeed simply accidents. However, the issue is that BGP connects every network, and a mistake propagates very easily. So, and on the other hand, it's a shared responsibility to keep the internet running, right? So. I think it's very important, and from our perspective as a vendor, we also try to obviously help customers implement RPKI and educate customers where needed. I think in general, but we'll get to that later. The origin validation as we currently do it with RPKI works very well. It's really good to see that adoption is still uptaking. So more networks are still deploying RPKI. And there's some work obviously for next steps, but I believe we'll get to that later in the session today.
Absolutely. Then John and Nathalie, really thanks for accepting our invitation. It's really great to have the guys from the actual registries talking, with the audience and sharing your thoughts. So from the registrar perspective, how RPKI can solve the problems, and what is that critical mass of the adoption where we would say, okay, this is good?
I'm happy to speak to that a little bit. It's interesting, by the way, just I listened to the panel, and I've been doing this a while. I think of BGP as that new routing protocol, because when I got involved in doing this, there was no BGP. Actually, routing was manually configured among the NSF backbone and the other interconnects, and BGP was the solution to our problems, allowing distributed multipath and failover routing. And so when it was introduced, I have a little bit of spot of sympathy. It is true, security wasn't considered the top priority, and that was mostly, as Nathalie said and others, everyone knew everyone. It wasn't a big thing. If you found a route you didn't like, you literally grabbed a snapshot of it, picked up the phone, and said, "Why are you injecting this route for this block with this AS number?" And it wasn't a problem. The fact is, the internet success has meant we need a second source. We need some way of validating the information we're receiving, because no one's going to pick up a holder of an address block, a way to publish out of band what's likely to be seen in routing. What do they expect to have routing look like? And that's important, because that lets someone do a good sanity check. So the whole point of RPKI, the fact is, if just one organization's doing RPKI, it makes things better, because that one organization is far less likely to have their routes hijacked by anyone who cares to pay attention to RPKI. We don't necessarily need a critical mass. It's really a question of, do you want to protect your own routing or not? So to that end, I would say RPKI is one of those great protocols. It's as successful as, for each person, it's a success the moment they turn it on.
Absolutely. And you actually made a very good point, that community knew each other by the time when internet was, was spreading around the globe. And the funny thing is that still, I think that the community is pretty small, considering, the scale of the internet. Absolutely. So moving to the more advanced things, and I would like to touch base around the, hosted, delegated, and hybrid RPKI type of things. So perhaps Nathalie and John, can you elaborate a little bit about how ARIN and RIPE NCC works with, hybrid, hosted, and delegated type of things, RPKIs, and what's the difference between them?
Let me talk a little bit about ARIN and RPKI. Briefly, we've been following RPKI since it was available in terms of the IETF doing its standards. I want to talk about why RPKI is important, the services we offer, and some details that are specific to ARIN and the ARIN region. So first, next slide on page 3, it's what we've talked about. RPKI information, because of the PKI element, the public key infrastructure, you know that you can cryptographically verify the information you receive is actually authentic, and that's important. We did have a way of telling people about routing information in the past, as Nathalie has suggested, the IRRs, the Internet Routing Registries. One Internet Routing Registry is a good thing. 5 is okay too, but we had some 40 some odd Internet Routing Registries, and a plethora of routing registries just isn't fun. You really don't know where to look or the integrity of the data. RPKI addresses that by us having signed repositories that people can pick up. They know the information is authentic and it's tied back to the resource holder. So there's two halves of RPKI, obviously. One is that you publishing your information, your attestations, so people know what routing they should allow for your networks. And then the other side, which is picking up that information, going and getting the repository, decoding it, and using it to improve your routing. So you actually don't listen to bad routes. You only listen to the ones that are expected. So you can think about deployment in two modes. Deployment of you publishing your own ROAs for your own routing attestations, and then you as a listener of RPKI information. And there are parties that are just doing one or the other. If you just want to improve the routing of the routing that you use to connect to the rest of the world, then you can actually just listen to RPKI, use that to filter your routes, and you'll have better routing. Of course, your own routing for your own network won't be improved. To do that, you have to tell the rest of the world what ASs they should expect you on, what autonomous system numbers, and they do that by publishing ROAs. So think of it as two halves: better listening and publishing your expectations. And as noted, if you do both, you're much less likely to be hijacked. Your routes will not be hijacked because you're publishing what you expect your routing to be. And you won't pay attention to hijacking of other route blocks because you're paying attention to what others say they want for their network block routing. Let me talk about ARIN for a moment on slide 4. So we've made it as simple as possible. For people who just want to publish the information about what ASs should be announcing their network, they can go into ARIN. They can turn around and request a resource certificate that we'll store and publish. They use our hosted model. They create the ROAs they want using the web UI or an API, and we store and publish those. And this model is very simple. You create the ROAs, ARIN publishes them for you. We'll only publish ROAs that match the resources we're managing. It's very simple. We have a lot of people successfully using it. Of course, there's a problem in that ARIN is in the circumstances of publishing your ROAs. If you want to use a different distribution model, or if you're concerned about the integrity of our service, in theory, we could generate a ROA on your behalf that you didn't approve. Now, in ARIN's case, the particular way we've done things, we actually make you sign your ROAs to submit them, and we actually have hardware validation. It would be very challenging for people to see an announcement generated by ARIN that they themselves did not cryptographically sign. But for some people, they want to control the infrastructure. They don't want to rely on their RIR. So for that, we have the ability to do fully delegated RPKI. Next slide, please, slide 5. So delegated, you run your own RPKI infrastructure. You run what's called a certificate authority. And in that certificate authority, you build your own repository of digital certificates, including the ROAs. And you link that into ARIN. And through that linkage, everyone can find out your repository and its contents. And so you're responsible for being responsible for running your own certificate authority and then your own publication service, because you need to publish your ROAs. You need to publish that repository out to the internet. A little bit of work involved, but if you're a very sizable organization, then running delegated is something that might be expectation. If you're a Fortune 500 or a major online service provider, it may be that you're expected to run this just like some organizations are expected to run their own DNS servers. So to that end, we have delegated. The IETF, in their wisdom, noted that some people want both. They want the ability to control the generation of their certificates, but they want to rely on their RIR, their regional internet registry, for the publication. So they don't have to run servers all over the world, because we have diverse server infrastructures. And for that, if you go to the next slide, slide 6, we have a hybrid model. And the hybrid model is using our publication service. So you run your own CA, you generate your own certificates, you have full control over that, and then you link to ARIN, and we do the publication for that. This is actually easier than it sounds, giving you the full power and privacy of running your own CA, but leveraging our infrastructure. There's software tools to do it. We see people increasingly looking at this sort of model. So we have delegated, hosted, and then hybrid, a sort of combination of each. Any one of these will let you publish your expected routing to the internet. I'm going to give a couple of quick details in the ARIN region because people ask about them. I might as well save some time. Next slide. So you have to have an agreement with ARIN to use our RPKI services. If we've issued you your number resources, you have an agreement. You have what we call a registration services agreement. But what if we didn't issue you your numbers? What if you got them before ARIN was formed in December of 1997? When ARIN was formed, we took over administration of the prior registry, what was called the NSI Internet Registry, which was the successor in turn of the GSI Registry, which was the successor of the SRI Registry, which was the successor of John Postel. So there's an unbroken line of registries, of which ARIN is the latest. When ARIN was formed, we told everyone, you don't have to sign an agreement. You don't have to pay us anything. We'll keep your entries in WHOIS. You'll have reverse DNS. You don't have to pay anything. You have the same services that you had the day that ARIN was formed. Well, RPKI wasn't those services. So if you want the new services that the community has spent money investing in developing, we need you to sign an agreement for services. It's pretty much that simple. We don't really have a lot of issues with this other than some people look at that agreement and go, wow, that's a lot of legalese that I have to go through. We've updated that RSA 3 times to make it less legal, more friendly. And we're still looking at it now to see if further improvements are possible. But if you're a legacy resource holder, yes, you're going to have to sign an agreement to get RPKI services. One more little nit in the ARIN region, if I can go to slide 8. We publish our information, all the information in the ARIN repository we publish, and the people who pull that information and use it, we call relying parties. And because of the nuances of US law, I actually don't know whether or not relying parties agree to use the information the way they're supposed to. For example, best practices for RPKI, as published by the IETF, say if you can't validate something because you can't get to a repository, you should fall back to not found status and route just as you are today without any validation. We actually tell people, yeah, we need you to agree to operate that way. We don't want people creating an inadvertent dependency on RPKI. It should be possible at any moment for any part of this infrastructure to go back down and not affect your routing. You should fall back to just the way you are today. Think of it as belt and suspenders. If we take away the suspenders, your belt should still hold you up. We like having the additional security. We like having the additional filtering, but you should not create an inadvertent dependency on it. This means if you're installing RPKI software and you're going to use it to pull data and use it to validate your routing, you'll find you can't pull ARIN's data by default. It doesn't happen. Somewhere in the software package you're installing, there's a switch that says use ARIN's data. And you have to set that switch for it to download and put up the appropriate linkage. The reason you have to set that is I need a positive acknowledgement that you know using ARIN's data is using it according to our agreement. I can't bind you to an agreement that you didn't consciously decide on. So if you're installing relying party software, RPKI validator software, for example, you're going to have a switch somewhere that says, yes, I do want to use ARIN's data according to their policies. Just be prepared because it does catch some people. They set up RPKI and they're like, how come I only see 70% of the internet? Okay, well, ARIN's out there with the other 30%. And just something to not get caught on. That's actually all I had. I think we did a good introduction. I just wanted to cover some ARIN nuances. I'm happy to take any questions.
Sounds good, John. So I guess that we will have a QA session after the initial introduction and the things around the RPKI. So great. Thanks a lot for the update. Now, talking from the network architecture type of things, what are the current obstacles that, managing the networks any enterprise could face Melchior. Perhaps you can share a little tips and around.
Yeah, sure. Yeah. So what I've noticed from conversations with customers and others who are looking to deploy RPKI is that it's technically all there, right? Basically, all networking vendors have implemented RPKI code, and indeed you can pull all the ROAS via validator, and so that technically everything is in place and works by now. There were some issues maybe at first when we start deploying it, and you always run into some unexpected things. But I think, and especially speaking for our implementation, it works quite well. But the most interesting part of deploying RPKI is the point where you flip the switch and you start rejecting invalids. That is still a very scary thing for many to do, obviously, because as network engineers, we sort of learn that the more routes you have in your global routing table, the better connectivity you have to the internet. And now all of a sudden you need to flip a switch and start rejecting, what is it currently, around 5,000 routes from that global routing table. So there's still quite some work to do on that part, I think, especially for folks who are on the side of monitoring and network insights to give more or provide more insights into what happens when I flip that switch. So there's obviously things you can do with flow monitoring, and there's tools that provide insights in what is your top 10 destinations, for example, you want to reach from your network. But I noticed it myself as well. When I enabled RPKI, I wasn't able to email the Dutch police force anymore, because they didn't create a ROA for a certain more specific route in which the mail servers lived. So that is quite unhandy, obviously. So I think that is currently the biggest challenge. For example, one of my conversations recently with a large service provider, it took them over a year to make sure that all their downstream customer routes were covered by a valid ROA as well. Where on one hand, technically it's relatively straightforward to configure a validator and set up that connection from your router and even build a policy. The rest around it is probably still the majority piece of work. So that is, if we would want to see an even bigger increase in adoption, then that is something we as an industry should look at.
Can I add something to that?
Absolutely, Nathalie.
Because I was studying for this webinar, I was studying some numbers today on adoption and what people are actually doing. Mm-hmm. And then I noticed that in the RIPE region, at least, it's 52% of all the routes originated in our region, by some definition. 52% of the routes have a ROA, which is really, really high. But then you look at what is actually happening in BGP, and for IPv4, the number of RPKI BGP announcements that are invalid, so a ROA says something different than what is happening in real life. For IPv4, that number is very low. There are not many invalids. And that is because it has direct impact. If somebody creates a ROA, like Melchior said, or creates a ROA and makes a typo in the ROA and does something different in real life, like the Dutch police, you can't reach their network anymore. You give them a notification like, hey, you should fix your ROA because it doesn't match with what you're doing. But with IPv6, it's rather high. It's 2.5% of the IPv6 prefixes who have a ROA do not match with what we see in BGP. So then the question is, are people massively hijacking IPv6? Which is not likely the case. But that is probably because if people create a ROA for IPv6 and they make a typo in it, nobody alerts them because people always forget to add IPv6 in their alerting systems and monitoring, etc. I think. So I thought that was just interesting to share. So if you create your ROAs, please provide equally attention to your ROAs in IPv6. I think that's a lesson.
Absolutely. And Ignas, perhaps you can enlighten a little bit, guys on webinar. What are the obstacles moving millions of IP addresses every day using RPKI? And what obstacles do we see in terms of the large IP holders where they can't delegate the whole LRI account for the IP addresses?
Yeah, of course. So delegated RPKI by default, it delegates all of the organization's resources, like to some specific, like control of the RPKI resources to some specific CA. But what happens when you like have certain parts running on your infrastructure and you only want to subdelegate that specific, let's say, subnets? And not all of those. So delegated or hybrid RPKI methods actually have a possibility to make another parent-child CA handshake where you would donate the specific ranges that you would wish to subdelegate it. So some form of subdelegation is possible. However, that would require not one but two CA servers in this case. Making RPKI delegation a fully automated solution, as if you already use a hosted RPKI solution, is actually also quite risky because after you switch from hosted to the delegated RPKI solution, you actually cut one. And for example, I know for sure that in ARIN's case, it's not yet fully automated. It actually creates a ticket which is reviewed by a technical person. And basically, if you're doing that after the let's say the technical person's shift's time, then you can actually lose your RPKI, or maybe not lose, but you're just in the risk of losing it. So probably most of network operators would try to, I don't know, omit that, and at least take that into account. Let's see. Actually, what would be better in this case if a hosted RPKI solution would be able to offer such functionality like you can currently subdelegate the control of whois data for specific ranges, that you could also subdelegate the control of RPKI control as well. That would mean that no more CAs would be needed, and basically everything would be controlled on the RIR side. I'm sure this presents more challenges and issues, but I believe that RIRs would be able to solve this. And that would actually make it easier for management purpose, because you would be able just to use, let's say, ARIN's API to control all the ROAS, and it would reduce both costs and time for RPKI management.
And the case for that, John, before you jump in, the case for that is that actually, there are sometimes, companies that have millions of IP addresses,
right?
But they do not want to delegate the whole, RPKI to us. Instead, what we do, we actually, try to educate them that they should go with their own hosted RPKI, to delegate some part of those IP addresses to our platform. But that also is complicated. And essentially, working with the large enterprises where we need to go over the security audits and things like that, opening the new ports, it's a hassle. So perhaps you have some answer on, what are the plans on kind of, giving that flexibility of RPKI from the registrar's side?
It's interesting because when we first did, for example, our hosted RPKI offer, our big concern at ARIN was that we would have the ability, our engineering team, our registration team, would have the ability to go in and create a ROA for a network without any of us being one of the authorized contacts to that organization. And we actually set up our system such that we have custom microcode in our certificate authority so that we literally, when you sign up for hosted, we put your public key in the certificate in our CA system. And since we don't have a private key, none of us can set up a row on your behalf. It's literally impossible for ARIN or ARIN's system to generate a request. Consequence of this was people said, oh, your hosted system is so difficult. I use APNIC and I use RIPE and it just point and click and it just generates it. And I go, yes, that's true, but that means it could be generated without you being there effectively. Someone could become you and generate this. And I talk to Fortune 500 companies and they're like, oh, no, the complexity isn't worth it. We'd rather have you have the ability to completely impersonate us even, but just have it be simple, than we would have to run pieces of it ourselves. So in fact, we're now looking at that, and we're now looking at the ability, exactly what came up in the conversation, what Ignas said, the possibility of us having people log in and be able to delegate parts of their authority on their account to other organizations. And it's a little, I mean, it shows a level of trust in ARIN and the other RIRs in that they trust us to operate this securely. I actually I slept much better at night knowing that we couldn't create a row on behalf of an organization, but I'll get over that. So yes, I think you're going to see more services at the RIR, more ability to fine tune. We have people who work as consultants or technical services for multiple organizations. And they're like, I want the ability to get assigned authority. Maybe I'm a network operator here and I also do their security. Maybe over here I do DNS and all I do is reverse DNS. But over here, I'm just doing RPKI. How do I get the privileges for the particular ARIN accounts that associate with what I do for a living? So we're looking at that right now, but that's a little ways down the road.
And, the next question actually popped into my head was that perhaps the registrars could be unified at some point with, the common standards like RPKI, WHOIS, etc., right? So perhaps what actually Fortune 500 companies told you that it's, too complex here, but it's easier in APNIC or RIPE, that perhaps registrars should work closer together to make this effortless and make it unified somehow. And I'm sure that it's possible.
I will say, we have heard at least in the RPKI space, people have been very clear to say, unlike WHOIS, which is updated only on occasion, they want real-time RPKI interfaces, and they want RPKI commonality. Common schemas, common API. We have a diversity of learning among the RIRs. And what we've heard is work towards less diversity. Now that we've all seen the benefits of various approaches, can we please aim for common targets? So I know the RIRs right now are spending a little bit of time trying to do things more in common with RPKI. And that actually opens up the door to registrars or front-end operators to do integration. It's a lot easier if you're working with 5 RIRs that are roughly similar and not completely different in their models. So I think you'll see more focus on the RIRs offering uniform services or more uniform services as we go forward.
Sounds good. So the ultimate question, what are the current obstacles for adopting RPKIs? And basically it of course touches the governance type of things and the actual enterprises or networks that speak with each other. So what do you think are, the things that could make RPKI adoption faster? Perhaps, Nathalie, you can.
Yes. First of all, there is a task for us, the RARs. What John just said, we have to work a little bit more as RARs for not only user friendliness, because that also comes, as John said, with a price. But we really, as RARs, I believe we have to do our due diligence very well. And with RPKI, we are now operating, serving as a trust anchor that brings responsibility because people rely on us. We're now getting more into the 24/7 routing operations. That brings rock solid infrastructure, but that also brings more transparency. What are we doing? Why are we doing it? Is what we're doing, is that secure? Security is also getting increasingly more important. RPKI, public key infrastructure, we work with keys, especially in the hosted system. Our members and end users trust us with keys, private keys. How do we deal with those? How do we store them? How do we keep them secure? All these things we are very well aware of, and we are putting a lot of effort in resiliency and transparency and security, all that. So that is one thing. To overcome hurdles of deployment, we have to, as RARs, take on our responsibility. And I see that we are taking on that responsibility. But we also want our members to tell us how we do and how we can do better, always. So that is one thing I think is important. Another thing is that we see a huge uptake in RPKI. If you look at all the adoption graphs, we see the line almost going straight up. And that's really cool. Most of the tier ones, so the big transit providers, are now doing route origin validation, so making routing decisions, which is great. What we do see is that the national level of operators, so there are the large ISPs in each country, basically, they don't make those routing decisions based on RPKI yet. And they also play a huge role. Internet exchanges, they are picking up route origin validation. But the big national providers, they are still lagging behind. So that is another burden. Today, again, I like numbers, so I looked up another number. What fascinated me was that 75% of our members from RIPE NCC have created a certificate in our dashboard. 75%. That's amazing. That's really high. But only 58% created their ROAS. So that's a user interface fascination that I have. So somebody clicked, yes, give me a certificate. Then they get the ROA dashboard where they have to make their routing statements. And they go like, oh no, that's a bridge too far. I don't know what to do here. So that there is also this learning and teaching that we have to do to help people a little bit, because it is a fascinating number that people say initially, yes, I want a certificate, but then not create those statements.
Absolutely. By the way, very kind of a little bit of topic. Do we know how many IP hijacks happen on a daily basis? Melchior or Nathalie or John, perhaps you have that statistics. It's actually very interesting.
John, I think you're muted.
Yeah, I think it's hard to report on that, but if I monitor social media quite intensively on this, and I mean, and obviously not all hijacks are reported, but for example, Doug Mattery from Kentic, he writes a lot about hijacks as well. He does a really good job there. I think on average there's a medium to major impact hijack on a weekly basis at least. I'm not sure what the others think about that, but if John, you're muted. But I think on average you could say that.
Right, got it. So can we say that the whole RPKI adoption on all of the networks would eliminate the hijack problem? Is it a bold statement?
Okay. So I'm gonna let me weigh in here because I need to be clear. So people who have locks on their house or locks on their automobile tend to get broken into less than people who don't have locks. But that doesn't mean they're not ever broken into. People who have two-factor authentication turned on for their accounts have their accounts hijacked less often than people who just use a flat text password. But that doesn't mean people who have two-factor turned on never have their accounts stolen. So let me now go to RPKI. If you have RPKI, the odds of you having your routes hijacked or somehow a capricious finger typo affecting you is greatly reduced. It's not perfect. We don't live in a perfect world. There's a number of very interesting attacks that can occur along the path. And historically, these have been very rare. They do occur. Like I've got a couple of papers I've seen that document one or two, but they're a whole nother level of technical sophistication to pull off. So when you say completely solve the problem, I have to ask, what's the problem? If the problem is the common route hijack, yes, it completely solves the problem. Does it mean there won't be more esoteric attacks? No, but hopefully they're rarer and fewer and far between.
Got it. Thank you very much. So, talking about the future and where we see it, perhaps Melchior, you can give in a few minutes a short update what's happening in IETF of making the RPKI more sustainable.
Right, sure, yeah. So for those who are not familiar with IETF, I won't go through the whole slide, but IETF is basically the organization that standardizes how the internet works and how protocols work. And they do that in different working groups. They come together 3 times a year. And in the meantime, they communicate via email. And it's around, well, the meetings typically see around 1,000 to 1,200 folks working for vendors, but also service providers, cloud providers, etc. And together we try to write these documents, RFCs, that define how a protocol should work and also that how it should interop between vendors, for example. Interestingly, indeed, as Nathalie and John just mentioned, implementation of these standards is up to the implementer. So IETF defines how it should work, but how you implement it, that's up to the one who is actually using it. So there's also some differences in how these protocols in the end work per vendor or per user. I think for this conversation, the most interesting working group to follow is CyberOps, the Secure Interdomain Routing working group. As the majority of RPKI and origin validation and BGP-SEC related work is being worked on in CyberOps. I started with creating a slide per active document being worked on in CyberOps, but as you can see, there's quite a few documents. It's a little bit too small to read, but as you can probably see, the majority of documents being worked on are actually about RPKI. So one of the things, obviously, that is, let's say, the next big thing in RPKI is path validation. Right, so currently what we just discussed is origin validation, where someone signs its prefix, and so you can validate that the ASN advertising the prefix is actually that it was his intention to do so. But if I spoof the ASN, then I can still advertise a prefix. Probably with a valid ROA. So there's work that is called ASPA, AS path validation. And so that is a really interesting one to follow. But as you can see, there's also quite a few drafts being worked on with regards to how origin validation and RPKI in general work. So I would definitely recommend to look up the CyberOps page on the IETF website. And a really interesting question just came up in the chat as well. But what about BGP-Sec? That is again becoming a discussion, and I mention again because obviously the BGP-Sec specification has been out there for quite some time already, but so far it hasn't really seen any implementation. Interestingly, the argument always has been, because what BGP-Sec does is, as you can see on the slide, you advertise something, you sign it with a key, and the next one in the AS path can validate your announcement, adds his own signature, etc. The thing here is, and the argument always was to not deploy BGP-Sec, is that it could be very heavy on control plane because validating signatures and so doing crypto on control plane it could mean that you'll burn CPU resources. Interestingly, currently the majority of networking vendors are using quite powerful CPUs in their routers. So there is some movement in favor of BGP-Sec. The downside of BGP-Sec is that it does not cover the AS path validation, as in the first one who actually injects the route and signs it with BGP-Sec still would need to sign or create a ROA for their prefixes, but also for once we see implementation, for example, for OSPA, still needs to be the legitimate holder of the ASN. Because the only thing BGP-Sec does is it signs the path. It doesn't check what you originally advertises. So basically, with every appendage we put on BGP, John already mentioned that earlier, and it came up in the chat as well. It's not there's not a single solution for that, right? So every time we will need to come up with another thing to solve the next hijack or the next issue in BGP. But I think if we see a BGP-Sec and AS path validation deployed together with origin validation, that is a pretty solid solution, at least for these BGP hijacks. There was a really short update on IETF. As I said, there's too many documents to go into every specific document.
Sounds good, Melchior. Thanks a lot for the update, and I guess many more things will come towards IETF, and I think that within the next 5 to 10 years, we will see a big shift in the way how the internet is developing, and the new solutions and standards are coming. And talking about the actual standards and the future of RPKI, let me throw a far-fetched idea. What if RPKI would become a decentralized vehicle that would be stored, anywhere on a blockchain, or, somehow it would be a self-sustained vehicle? What are your thoughts, Nathalie, John? It would be really great to hear your input here.
Yeah, I'm curious, because when I hear something like that, I have more questions than opinions, to be honest. Because my first question would be, so there would not be a root, so everybody knows everything. How quickly would a change populate, and can somebody decide not to acknowledge that change? And would BGP catch up with that quick enough? What would be the problem that we're solving? like I said, I have more questions than I can debate this for hours. But I'm curious to hear John on this, to be honest.
Nicely done, Nathalie. So ARIN's approach to such questions, those are technology questions. And the particular technology that's used, whether it's RPKI or whether we're talking about, RDAP or any other technology that's used to operate the registry, the community works both with the RIRs and with the IETF to specify the protocols and the technology it wants to use for this. If the community comes up with new protocols and tells ARIN, just like it did with RPKI, please have a role here and run some of this, we'll run the infrastructure. And when there's new protocols, if they tell us to operate according to new protocols, we'll go grab the RFCs and operate according to the new protocols. The technology choice is really up to the community. I will say there's certainly trade-offs with any technology, and a distributed ledger technology immediately raises some interesting questions about commitment of transactions and how that occurs.
Exactly.
What would be the voting algorithm or the weighing algorithm for commitments to a distributed ledger. There's some pluses and minuses that occur in a distributed ledger environment. I certainly have circumstances where I've had companies that say, quite frankly, they've moved resources into the ARIN region because they know how we're governed, and they know how we operate under law, the laws that are applicable to us, and they understand the control of their resources that results from those two things: our contracts, our legal incorporation, and our governance model are sufficiently understandable to them that they're willing to invest $1-2 million in an address block and know that the asset that they've obtained for their estate, those digital rights, that they are now able to protect them in a court. If you tell them that they're going to do the same thing and it's going to end up on a distributed ledger that's as safe as all the other distributed ledgers out there, don't be surprised if they balk about getting involved in that. We've seen some notorious blockchain built systems fail, and that's generally not something that people want to build a reliable infrastructure on. That's not to say it can't be built, but you have to build it and then you have to instill trust in it. That's a pretty important task.
After the dot-com bubble, some of the countries wanted to actually ban the internet. So the point that I'm getting to is, you remember, John, in the last ARIN event, when Jeff Huston was telling about, how we should look in the whole internet infrastructure, and we should kind of think about the new ways of shifting the internet, because right now what we do is we use 80s technology with 90s hardware, basically. Well, sort of.
So, but when you build a house, John made the lock analogy earlier. When you build a house now, the house should be there in, let's say, ideally at least 50 years, right? So you have to make sure that the foundation is right, and then you have to build the actual house and pick the right materials. And with the knowledge that you have today, you might want to make that sustainable and stuff like that. And then you want to put, when you have this perfect house for today, that you hope will be there in 50 years, you continuously make improvements on the house, right? At some point, you want a new kitchen. And I think that works with this technology as well. We're adding new things, like, for example, what Melchior explained with BGP-SEC, RPKI. We're building things on this old protocol, but that doesn't make it a bad protocol. It just, we keep improving. And I think
Yeah, so the foundation here is actually the actual registrars. This is the foundation. This is the foundation.
Well, if I may add, I'm obviously not a register, but I think in principle it is already distributed, right? We have 5 regional internet registries around the world that indeed are covered by different laws and regulations that are in different parts of the world, and I think are doing a really good job. So, and obviously there's always challenges, and there will always be discussions, and things should be different and better, etc. But I think in general, the registries do a really good job. So the first question should be, why should we even want to change something? Right? The system works actually quite well. And there's always an alternative technology, and you can always do things differently. Look at car manufacturers, right? There's obviously the traditional cars with a petrol engine, and there's the cars that run on electricity, etc. And there has been experiments with all different kinds of ways to fuel a car. But as Nathalie said, the system works, right? So why would you personally want to do something different?
Because of the pollution.
I'm not sure if doing blockchain helps to reduce pollution.
No. So
much
the car manufacturing is.
No, sure, okay.
Yeah.
Right.
But when we talk about how sustainable the internet is, so yes, absolutely, registrars do very good job on keeping the internet governed very well. The thing that I was trying to kind of get to is, what if we would have the more unified type of things, as previously John said about the different interfaces and things like that. Even the whois data different in every registrar. So my point is here that IP address, either it's in Europe, either it's in States, it's the same IP address, but the regulation is slightly different. And if we would come up to a unified type of thing, where everyone would have the same set of
that
things.
isn't a technology problem. That's a policy and political problem. So you don't have
It's
to
a governance issue.
Right. Yeah, exactly.
Sometimes yes.
And just to think about something, you talk about 80s technology and 90s hardware. It's not quite that bad. It might be 90s technology and 2000 technology to run networks that may be built with the last 10 years hardware. But recognize now, this is becoming very important to economies everywhere. Governments aren't looking at the internet as, oh, that's like 2%. That's like my radio business or my television or my film industry. They're realizing the internet is under 25 or 30% of their GDP is dependent on the internet. And the governments are waking up going, where's my Department of Internet? Where are the knobs on this? How do I exercise my public duties that they have to their public to govern the way that their public expects it to be governed? Now, that's a hard issue with the internet because, well, everyone's got a piece of it and no one controls the whole thing. But you have governments waking up to the fact that this internet is incredibly important. And only now are they coming to grips with the current structure we've done in the internet community with how we handle domain names and how we handle IP addresses. And they're waking up going, more decentralized? No, they're looking at a much more centralized approaches. Why isn't this administered by every government out of a government office? To go get your IP address block, go get your internet license, and we'll give you an IP address block at the local government office. So I understand when you talk about distributed blockchain, but I just want to say the people at the table for the conversation of how this all works are not just registrars and they're not just ISPs. they're now a much bigger community, and they may not be in favor necessarily of a distributed blockchain answer.
And this is the thing, that who is actually that community? Is it the LRI, or are those the home users? Who they are? Who are they?
Valid point. This comes up with the registries themselves. We have parties affected by the RIRs that don't hold number resources. Researchers want information from our registry. They may not be the rights holder of any block, but they need them to do their job. Law enforcement, similarly. Absolutely. They're an affected party, even if they're not a resource holder. And so, yes, the tent is much bigger than you might imagine.
Absolutely. We have a QA part, questions and answers, but I don't see any questions. Perhaps audience has some questions, and we can.
Yeah, we casually answered some in the chat here and there.
Yeah. Great interaction, Nathalie.
But I would love to take some more questions if there are any.
I don't see any coming. And actually, I think that we should do the second part of this session, because the discussion where it's going really, going the right way, and we definitely have to talk more about the new view, a new view, or a new type of things that could be adopted. I'm a true believer, actually, that sometimes technologies can solve the governmental issues at some point. And in my view, that we definitely have to be, with a much broader vision, what the internet will look like after 10 years, 20 years, So we definitely should not close the loop of the current technologies that we have today, but perhaps introduce, and look more into the future, what can be adopted in the future. John, perhaps you can give some of the future insights as your wrap-up.
Sure. Consider the fact that while we have a lot of attention right now on the registries because of IPv4, IPv4 is an interesting situation. The fact is that parties that are growing rapidly are having rapidly changing economics. It made a lot of sense to get one more address block and keep doing things with v4 5 years ago for some of these organizations, or even today. But as we go forward, the part of the internet that's growing the quickest is the mobile side, and the mobile side is entirely using v6. It's becoming rarer and rarer to find a mobile operator who isn't using v6. Even broadband, some of the broadband networks have switched to v6 as their transport, with v4 effectively an overlay service. So when the part that's growing the fastest is using v6, I tell people, yeah, we're going to have a tipping point. We're going to have a point in time where the vast majority of the internet is IPv6 and v4 is in the minority. That may only be 20 years from now, maybe 10, but I'll say between 10 and 20 years from now. At which point, the most exciting part is that the costs currently borne by organizations to work with v6 and v4 at some point are going to fall. Meaning the parties that are paying gateways so they can talk to v4 will say, nah, that's actually not our job. If you're running a v4 only network, it's your job to pay that cost. You have to figure out how to talk to v6. We're not going to make this dual home. We're not going to make this dual stacked. We haven't had that yet. Everybody working with V6 very nicely works with V4 as well. But that's the next big change. It's probably 10 to 15 years out, at which point V4 only networks are going to very quickly get to learn the pain of translators and more cost. And so we have this, that's the tipping point event. When someone asks, why will V4 disappear? It won't. Someone will have a V4 printer in their house or a TV or all sorts of things. But in terms of an organization that's growing, an organization that's expanding, an enterprise network, they're going to see the cost change dramatically as we get to the last 20%. And so that means when you start thinking about investment, if you're not thinking about IPv6 investment, you've set an end date on yourself. You have an expiration date. I don't know what it is, but it's not more than 20 years out.
Thanks, John. What about you, Nathalie?
Yeah, I was a IP6 program manager for almost a decade. And when I hear John say 10, 15 years maybe, I wish I was that optimistic, to be honest. But for that tipping point, I've been looking at the graphs for years, and every year there was 2% more, and I was like, yay, 2%. But yeah, I hope you're right, John. I'm rooting for it. What I'm concerned about is something completely different in the future of the internet, and that is the centralization. We saw that today again. One big party has a big issue, and everything goes down. And we really have to consider this. This is not what the internet was designed to be, to have just 3 or 4 big pillars where everything is relying on. And this worries me. The trend is still going towards more centralization, with more things relying, where if somebody makes a configuration mistake or a policy mistake like today, it has massive consequences. And you would not want, with all these things that we're plugging into the internet, hospitals, road signs, metro stops, whatever, that we are just relying on 4 parties that can make a configuration mistake. So that is something that I want the world to think, be more aware of, and consider that. And yeah, that's my hope. It's less optimistic as John, but yeah.
You know, 5 years ago, we said that IPv6 will come after the 5 years. So yeah, it's a long journey for that. Melchior and Ignas, perhaps you can wrap up the webinar with your last words, and you know, where do you want to see the internet going next?
Well, to come back to IPv6, I really don't see, what is it, 240/4 and 0/8 happening and things like that. I mean, just imagine what kind of changes would be needed. There are still many computers connected to the internet that are so outdated that the software they run, that you can simply not update them, apart from ASICs in routers and switches that you probably cannot reprogram. They're still very old devices running the internet partly. So I really don't see that happening. So I would be in big favor of seeing more V6 adoption. I think, as what John just said, many mobile operators, and you see that in statistics as well, in countries where there's no fixed internet connectivity, that the majority of traffic is already V6. The thing simply is that V4 is still not expensive enough. Right? I mean, it's still for an operator more expensive to change their OSS BSS systems than to purchase another block of V4. And I think at one point there will, and I totally agree with what John said, there will be that tipping point somewhere where the economics at one point don't work anymore. I think the good thing is that if you look at how far implementations are, technically I think we're ready for V6. I mean, the majority of protocols work over V6. You can by now operate your data center fully on V6 and overlay V4. So that is the foundation is there. So I hope I'm on John's team in this case. We see full V6 adoption a little bit earlier. And as with regards to decentralization, it's really interesting because at one point operators do want to build decentralized routers. They build IP fabrics in ways where there's no centralized control plane, but you distribute policy with BGP, LS, and other things. And on the other hand, the companies itself are centralizing. So really interesting challenge. I think it is something that happens by nature because you see that happening in any other businesses as well, where companies buy each other and you end up with a few large ones. But at one point, you will always see new companies coming and focus on niches. So that is on itself a good thing. I think the worry is maybe a bit bigger with regards, indeed, as what already was mentioned, governments who are interested in interfering with internet routing. You already saw that happening obviously here in Europe with the recent events where one country wants or asks others to take down the other country from the internet. I think that is probably a bigger concern, and it ties into indeed a few larger companies basically running the internet. So that is definitely something to keep in mind and to think about how to handle those situations.
Absolutely. Ignas?
I'm actually on Nathalie's side. I think IPv6 adoption is going a bit too slower than expected, of course. And as Melchior mentioned, there's still quite a lot of hardware on the internet running, like old hardware running on the internet, which is still not capable in adopting IPv6. And even though there's, I would say, a huge advancement in let's say, 5G networks and stuff like that, I think, especially with options like leasing, and if those are enforced by sub-delegation efforts put in by the RIRs themselves, I think this would even further push the IPv6 adoption a bit further away.
Thank you. Yeah, I mean, there are a lot of opinions around the IPv6 adoption, but in my opinion, is that we still have to live with the IPv4, and we still have to maintain it. And we can't ignore that fact. And, making the IPv4 more accessible, that is the pain of adopting the IPv6. And for that, actually, we can deploy a much smarter RPKI type of things, right? Where we can, subdelegate some of the resources, some of the resources that are actually holding the large enterprises, which they actually received even before the registrars appeared in this world. So I think that sustainability and the solutions around the IPv4 is still a case, and John wants to say a word.
I just want to say I agree with you. Actually, I don't take my rant as a vote against V4.
Absolutely
keep
not.
Doing V4, keep
Absolutely
it running, but do V6 in parallel. What I'm saying is, if you do them both when you're deploying your infrastructure, then you're ready for the future. If you just get another address block and just do V4, please understand you're delaying a major problem. It will catch up with you. Do both. So yes, keep V4 running. Let's keep it going as long as we can. But that should be in addition to the V6 you put on your interfaces.
you know, I think that we definitely will do another session about it, and you know, I think that it would be really make sense to do a webinar about the actual standards, the internet standards, and you know, the way we could make the internet more durable. Let's put it this way, and. You know, a couple of months ago, actually, I found the Verge article that was published interviewing FBI, where we said, okay, guys, IPv6 is coming, but who's going to maintain all that WHOIS data? So let's keep it for the next webinar to talk. And guys, you are wonderful. Thank you very much for jumping into this webinar. Really great insights, really great information. Thank you very much. And have a lovely day, evening, or morning. Thanks.
Thank you.
Thank you.
Thanks.
Bye.
Bye-bye. See you.